Hello everyone, welcome back to our channel Problematical. Today we'll discuss miscellaneous exercise on chapter 12. First question. Three vertices of a parallelogram ABCD are given. Find the coordinates of the fourth vertex. Now it's given to you that it is a parallelogram. We know that parallelogram has opposite sides as equal. So we'll draw a parallelogram, name its vertices, the three given, and the fourth one will be considered as XYZ. A, B, C, D. Whatever sequence is given in the question, the same sequence is to be followed while naming the vertices of parallelogram. -1, 1, 2, and the coordinates of D will be X, Y, Z assumed by us. Now, since ABCD is a parallelogram, it's given. Therefore, AB will be equal to DC and AD will be equal to BC. Now, this is one way of doing it. If you compare AB with DC, you'll get an equation in terms of XYZ. If you compare AD with BC, you'll get another equation in terms of XYZ. Now, this will lead you to two equations and three unknown variables. We know that you can get the exact values of unknown variables as long as they are equal to the number of equations. So if you have two unknown variables, you have to have two equations, a minimum of two equations to get the exact values of those unknown variables. Here you have three unknown variables and two equations. So you will not get the exact value of X, Y, and Z. So what else approach can we take? You also know that in a parallelogram, your diagonals, they bisect each other. That means if the diagonals meet each other at a point P, then that point P is equidistant from each of the from the points A and C, as well as equidistant from B and D. So let us name this point as P. This point P is equidistant from these points, which means that P is the midpoint of AC and P is also the midpoint of DB. Let us name this point P as X1, Y1, Z1. Our target is to get the value of D, but we will use P to get to the value of D. Now, P is the midpoint of AC and P is the midpoint of BD. So one approach would be calculate the value of point P and then use section formula to get the value of D. Second approach would be, or the midpoint theorem to get the value of D. Second approach would be directly equate these number of equation of these points. So we will not equate them. We will calculate P first and then D. Point P, X1, Y1, Z1 will be equivalent to, by midpoint theorem, the end coordinates of A and C are to be averaged. That means 3 plus of -1, which means 3 minus 1 divided by 2. -1 divided by 2, 2 minus 2, 2 plus 2 divided by 2. Should be addition, right? Average. -1 plus 1 divided by 2. So, this will give you 2 by 2, which is 1, comma, -1 plus 1. These both will get cancelled. You get 0. And 2 plus 2, 4 divided by 2 is 2. Now, we know that you can apply the section formula over here. This is point D. this is point B, this is your point P, and it is dividing BD in the ratio 1:1. B point's coordinates are 1, 0, and 2. B points are given, coordinates of B is given 1, 2, and -4. Coordinate of D is X, Y, and Z. We know that bisection formula or by midpoint theorem, coordinates of point P, 1, 0, and 2 will be equal to X plus 1 divided by 2, Y plus 2 divided by 2, Z minus 4 divided by 2. Equating these, we get X plus 1 divided by 2 is equals to 1, implies X plus 1 is equals to 2, which means X is equals to 1. Similarly, you'll equate equate for Y coordinates and Z coordinate. Z plus 2 upon 2 is equals to 0, which means, Y plus 2 upon 2 is equals to 0. Y plus 2 is equals to 0, and Y is equals to -2. Z minus 4 upon 2 is equals to 2. Z minus 4 is equals to 4, which means Z is equals to 8. So with this, we got the coordinates of D as 1, -2, and 8. Next, find the lengths of the median of the triangles with vertices given. So you have to find the lengths of the medians of the triangle. So let's draw a triangle first. Triangle's coordinates are given: A, 0, 0, 6, B, 0, 4, 0, and C, 6, 0, 0. Median. A median is a line which joins your vertex with the midpoint of the other side. So a line joining the midpoint of the other side would be considered as a median. In any triangle, irrespective of the nature of the triangle, all medians will always meet each other at a single point. So this median, AD is the median, so it will divide BC into 2 equal parts. 2 equal parts, and this will also be dividing it into 2 equal parts. Fine. You have to find the lengths of the medians of triangle with this vertices. That means your target is to get the value of AD, CE, and BF. Now, to get the value of AD, you should know the coordinates of D. To get the coordinate of D, you can observe CB. D is the midpoint of CB. D is the midpoint of CB. Since this is true, therefore, point D will be equal to 6 plus 0 divided by 2, 0 plus 4 divided by 2, and 0 plus 0 divided by 2. This is using midpoint theorem. You'll end up with 3, 2, 0. Next, similarly, your F and E are midpoints of AC and AB respectively. Therefore, we can get the value of F as, applying midpoint theorem, 0 plus 6 divided by 2, 0 plus 0 divided by 2, and 6 plus 6 divided by 6 plus 0. 6 plus 0 divided by 2. This will be equal to 3, 0, 3. And your E point will be equal to One second. E point will be equal to 0 plus 0 divided by 2, 0 plus 4 divided by 2, 6 plus 0 divided by 2. This is equals to 0, 2, 3. Now that you have these points, all you have to do is apply distance formula. So AD is equals to, you have the coordinates for A as well as G, root of x2 minus x1. So we'll consider D as x2 and A as x1. So 3 minus 0 divided by 3 minus 0 whole square plus 2 minus 0 whole square plus 6 minus 0 whole square. This is equals to 9 plus 4 plus 36. 49. BF is equals to root of 3 minus 0 whole square plus 4 minus, 0 minus 4, 0 minus 4 whole square plus 3 minus 0 whole square. This will be equal to 9 plus 16 plus 9, which is root 34. CE is equals to root of coordinates of point E are 0, 2, 3. So 0 minus 6 whole square plus 2 minus 0 whole square plus 3 minus 0 whole square. This is equal to 36 plus 4 plus 9. Again, this is equal to root 49, which is equals to 7. So by this understanding, the lengths of the medians would be 7, root 34, and 7. And by observing these values, you can easily say that it is an isosceles triangle. If the nature of triangle were asked, then you can, sorry, it's not an isosceles triangle. It's not an isosceles triangle, sorry. By this, you can say that two medians are equal. That's it. Next. If the origin of the centroid, origin is the centroid of the triangle PQR, that means the centroid coordinates are 0, 0, 0, with vertices P, Q, and R values are given in terms of variables small a, small b, and small c, then you have to find the values of small a, small b, and small c. Let's draw the triangle first. Now, we know that if C is the centroid, of triangle PQR, since PQR coordinates are used, here P is 2A, 2, 6, Q is minus 4, 3B, and minus 10. R is 8, 14, 2C. If this is a scenario, we know that centroid is given by x1 plus x2 plus x3 upon 3, y1 plus y2 plus y3 upon 3, z1 plus z2 plus z3 upon 3, where x1, y1, z1 coordinates of P, x2, y2, z2 coordinates of Q, and x3, y3, z3 coordinates of R. So by this information, we can say that C, which is the origin, so its coordinates are 0, 0, 0, will be equivalent to applying x1 as 2a, x2 as -4, x3 as 8, and so on. We get 2a minus 4 plus 8 divided by 3, 2 plus 3b plus 14 divided by 3, 6 minus 10 plus 2c divided by 3. Here, you will equate them, equating both sides. We have 2a minus 4 plus 8. So 2a plus 4 upon 3 will be equal to 0. 3b, 14 plus 2 is 16. 3b plus 16 upon 3 is equals to 0. 2c minus 4 upon 3 is equals to 0. So 3 and all three values will go on the right hand side and merge with 0. So 3 into 0 is 0. You have 2a plus 4 is equals to 0. 3b plus 16 is equals to 0. And 2c minus 4 is equals to 0. So your a value is equals to minus 2. B is equals to minus 16 upon 3. And C is equals to 2. These are your required values. Next, find the coordinates of a point on y-axis which are at the distance of 5 root 2. It should be root 2. Which are at a distance of 5 root 2 from the point P. So you have to find the coordinates of a point on y-axis. So let's consider this distance because the distance is given to you. Let this unknown coordinate be Q. P is given to you 3 minus 2, 5. Now it's given that find the coordinates of a point. Q is a point on y-axis which are points, coordinates of a point which are at a distance of 5 root 2 from the point P. So this distance is 5 root 2. It's given that this distance is 5 root 2. Now what will we do with this information? And what do you mean by the point lies on y-axis? In general, the coordinates of x would be x, y, z. But since the point lies on y-axis, its x and z coordinates will be 0. Which means that this Q passes through a line which is your y-axis. Okay, now we can apply distance formula here. PQ is equals to root of 0 minus 3 whole square plus y minus of minus 2, which is y plus 2 whole square plus 0 minus 5 whole square. And PQ is given as 5 root 2. Okay, so 5 root 2, and we are squaring both sides. So this is equals to root of 3 square 9 plus y plus 2 whole square plus 5 square 25, and you're squaring both sides. 5 square 25 into 2, 50 is equals to root and square will nullify each other. You're left with 9 plus 25 plus, expanding this, y square plus 4y plus 4. So you can solve this. You have y square plus 4y, 29, 38, 50 minus 38, 12. On the right hand side, minus 12 is equals to 58. Yeah. So expanding this, you can use middle-term splitting method. You have y square plus 6 into 2. 6y minus 2y minus 12 is equals to 0. y in common, y plus 6 minus 2 in common, y plus 6 is equals to 0. Y minus 2, y plus 6 is equals to 0. Y is equals to 2 or y is equals to minus 6. So there are two values of y in this scenario. Therefore, the required points will be, therefore q is equals to either 0, 2, 0 or q will be 0, minus 6, 0. Hence, find the coordinates of a point which are at a distance, hence this r. That means this point is at a distance, this point and this point, they both are at a distance of 5 root 2 from point P. A point R with x coordinate 4, hold on, yeah, with x coordinate 4 lies on the line segment joining the points P and Q. Find the coordinates of point R. A point R is given and it lies on the line segment joining points P and Q. So we've left with x coordinate 4. So we've let this information, a point R lies on the line segment joining points P and Q. So let's draw this. So you have P and you have Q. Let point P be 2, minus 3, 4 and Q is given as 8, 0, 10. Now point R lies on it, we'll name it R. You have to find the coordinates of R, fine. A point R with x coordinate 4. Now ideally we would have taken x, y, z, but x coordinate of R is already given as 4. So this is 4, y and z. Now we do not know, we do not have any other information. So what we'll do is, we'll consider this PQ, this R point, to divide PQ in the ratio k is to 1. Let point R divide PQ in the ratio k is to 1. Now applying section formula, bisection formula, what can you say? Coordinates of point R can be given as k into 8, 8k, plus 1 into 2, 2, divided by k plus 1. Similarly, k into 0, so 0k, minus 3 into 1, 3, divided by k plus 1, 10k plus 4, divided by k plus 1. Now you'll equate both sides. Equating 4 with 8k plus 2 upon k plus 1. So equating both sides, we have 4 is equals to 8k plus 2 upon k plus 1. And take k plus 1 on the other side. 4 into k plus 1 is equals to 8k plus 2. That means 4k plus 4. Taking 8k on, okay, is equals to 8k plus 2. This on the left side, this on the right side. You have 2 is equals to 4k and k is equals to 1 by 2. So k divides, R divides PQ internally in the ratio 1 is to 2. K's value is 1 by 2. So this is 1 and this would be 2. So PR is 1. RQ will be equivalent to 2. Not 2 units, but 2x. Now what do we need? We need the coordinates of point R. That means we need the values of y and z. We were equating both sides. So we'll continue with it. Y is equals to 0k minus 3. So it's minus 3 upon k plus 1. K's value is 1 by 2 plus 1. This is minus 3 upon 3 by 2. This will be minus 3 into 2 by 3. 3 gets cancelled. You're left with minus 2. Again, your z will be equivalent to z is equals to, k's value is 1 by 2, so 10 into 1 by 2 plus 4 upon 1 by 2 plus 1. This is equals to 5 plus 4, 9 upon 3 by 2. This is 6. So you have the values of coordinates of point R will be equal to 4, minus 2, 6. Next, if A and B are 2 points, be the points given respectively, find the equation of set of points P such that PA square plus PB square is equals to K square. K is a constant. Now K value is not given to you. The equation is PA square plus PB square is equals to K square. Coordinates of P are not given, and you have to find the equation of the set of points P. That means you'll represent P in terms of x, y, and z, and your final equation will be in terms of x, y, and z, and k is a given constant, x, y, z will be the variables. A and B coordinates are given 3, 4, 5, and B will be minus 1, 3, minus 7. Now, what you can do is you can take PB on the other side. It's PA square, so let's directly calculate it. PA will be root of x minus 3 whole square plus y minus 4 whole square plus z minus 5 whole square plus PB square will be x plus 1 whole square plus y minus 3 whole square plus z plus 7 whole square is equals to k square. Now here you have squares of these values. PA square, so you calculated PA and you took your square. PB square means PB is the root value and whole square. Square and root will nullify each other and we'll expand the internal values. So it is x square minus 6x plus 9 plus y square minus 8x plus 16 plus z square minus 10z plus 25 plus x square plus 2x plus 1 plus y square minus 6y plus 9 plus z square plus 14z plus 49 is equals to k square. Now, x square is 2x square plus y square, 2y square plus z square, 2z square plus minus 6x plus 2x, so it is minus 4x minus 8x, 8y should be. Yeah, minus 8y minus 6y minus 14y minus 10z plus 14z is plus 4z. So you have 2x square plus 2y square plus 2z square minus 4x minus 14y plus 4z. Now constants. Which constants do you have? You have this 9, 16, 25. 16 plus 9 is 25. 25 plus 25 is 50. 1, 9, 10. 50 plus 10 is 60. 60 plus 49, 109. So, plus 109 is equals to k square. Either you can leave it at that or you can take the constant on the other side. You're left with 2x square plus 2y square plus 2z square minus 4x minus 14y plus 4z is equals to k square minus 109. You can also take 2 common from the left hand side. You'll be left with x square plus y square plus z square minus 2x minus 7y plus 2z is equals to k square minus 109. Now 2 can be taken on the right hand side. You're left with x square plus y square plus z square minus 2x minus 7y plus 2z is equals to k square minus 109 upon 2. This concludes this exercise. Thank you.